This video will work through some examples of mean smoothing, otherwise known as numerical smoothing, looking at both odd group sizes and even group sizes with centering. And so firstly, just a quick recap. What is it that we mean by smoothing? So we're looking at time series data and looking at a process where we can remove some of the fluctuations that we tend to see in time series data. It helps us at times to reveal what the underlying trend is by smoothing out those fluctuations and giving us a clearer picture of the data. In this section, we're going to be looking, as I said, at mean smoothing. So we are finding the mean of groups of data points, or the average as we traditionally know it. The group sizes are specified each time. The data is usually provided to us in a table, so it's unlikely that we get a graph. And we're likely to only be asked to smooth a particular time period set of data points, so rather than a whole graph or a whole table worth of data. The graph we have here is just an example of how effective smoothing can be. So if we look at these black points, they're the original data, and we can see quite a few fluctuations there. The green points here is an example of what we call 3 mean smoothing, so using groups of 3 points of data to smooth. And the purple is 5 mean smoothing. So you can see the purple is actually quite effective, but the impact that has is a loss of data. So in a small data set, that can be quite an impact. So firstly, we're going to look at what we do when we're smoothing odd-sized groups of data. So that means we're smoothing groups of 3 points, 5 points, 7 points, and so on. When we smooth an odd-sized group of data, the smoothed value aligns with the middle time code in the group. So for example, if I was to smooth days 1, 2, and 3 in this data, my answer would line up with day 2. And so that does mean that we have no data value for the day number 1, because it's not possible to form a group of 3 data points around day 1, or day 1 being centered. In the next few slides, we're going to look at 3 mean followed by 5 mean smoothing. And so using this example from the previous page, we have the time in minutes that Liv ran each day was recorded for 9 days, and these times are shown in the table below. We are going to perform a 3 mean smoothing on this data set. So that means we're going to take the time values and we're going to group in data sets of 3 and find the mean of those values. So if I begin with the first 3 values here, so again we said day 1, 2 and 3, concentrating on those numbers 22, 40 and 28. And so what I'm actually doing here is I'm going to find the average of those numbers, and it will line up with the day 2. So 22, 40 and 28, and find the average, so divide by 3. And that gives me a value of 30 rounded to to the nearest whole number. And so if I was to continue along the line here, my next group of 3 would be day 2, 3 and 4. And here my answer would go in line with day 3. And again, 40 plus 28 plus 51 divided by 3. And I get a rounded value of 40 there. Each time I'm moving along one row or one column in the table along one data point. So now I'm in line with day 4. And so I've got 28 plus 51 plus 19. Again, divide that by 3. And I get the value for day 4 rounded to 33. I continue in this way until I have values for all of the table here. And so I would end up, if I'm just to write these underneath, for day 5, I would get a value of 43. And remember, all of these are rounded to the nearest whole number. 37 for day 6, 43 for day 7, and 39 for day 8. Again, as we said in the previous section, we wouldn't have a value at day 1 or day 9. So when we are smoothing in groups of 3, we actually lose one data point off each end. And so if we think about the fact that we are grouping 3 numbers together, and our answer will line up with the middle day or the middle time code of that particular set, it's not possible to form an answer for day 1 because we don't have any data here at day 0. Similarly, at the other end, we don't have any data at day 10. So we're unable to make that group to get a value for day 9. So the last possible value I can get a result for is day 8. And so looking here at the result, we now have our smoothed values written underneath our table here. And I've plotted those on the original graphs just so we can see the effectiveness. And so sometimes you are asked to comment on the effectiveness of the smoothing technique. And so we can see here that there is an underlying increasing trend. Okay, that may still have been slightly evident in the original data. It certainly has taken out the extreme fluctuations and brought the data more into the midline of that particular trend. But there still are fluctuations there. And so it has been somewhat effective. And so sometimes it might be more effective if we increase the group size of our smoothing. And so here, if we look at 5 mean smoothing, we are again taking a group, this time of 5 data points, and finding the average or the mean of that data set. So if we look at the table here, that means we are looking at days 1 through to 5. So the value or the answer for that group will sit in line with day 3. And to get our values there, we would be looking at the average of those first 5 data points. So 22, 40, 28, 51, and 19. And so our answer there on day 3, when we average those, so divide it all by 5, we end up rounded off to the nearest whole number. We get 32 as our smoothed value there. And so if we look to repeat the process from before, I'm going to shift across one box, one data point, and now go from days 2 through to 6, meaning my answer will go in line with day 4 now. And so again, I'm going to add those values, 40, 28, 51, 19, 60, divide by 5, and I get my smoothed value, again rounded, to 40. And we repeat that process again. Again, moving along 1 point. So I've got 3 through to 7, and this time my answer will go in the middle at time code 5, or day 5, and 28, 51, 19, 60, 33. Divide that by 5, and again rounded, my answer there for day 5 is 38. I continue repeating, moving down, and the remainder of my values there at day 6 will be 40, day 7, 39. Now, much like before, you may notice that we cannot find a value for day 8 or 9. So if we think if day 8 has to be the middle of a group of 3, that means that we would need data for day 10, for day 8 to be in the middle, of a group of 5. So there's not possible to get data for day 8 and 9, and for the same reasoning, we're unable to find data for day 1 and 2. And again here, if we look at the impact that that smoothing technique has had, so 5 mean smoothing, yes, I would say it's been very effective here in the graph. We've removed most of those fluctuations. Our data is very even. We have a small increase at the beginning, and then it's quite stable. The issue for this data set though is I started with 9 days worth of data and now I only have 5 data points left. Right? So by smoothing that data, I've almost halved my data set. So it makes it really difficult to make meaningful interpretations about what's happening in the longer term with this particular trend, because now we've got such a small snapshot of data, but very effective in the smoothing out of those fluctuations. It's possible sometimes that our smoothing technique needs to work with even-sized group numbers rather than odd. So that means we're working with data in groups of 2, 4, or 6, or so on. The problem with this technique of smoothing is that when I find the smoothed value for, say, a group of 4 data points, if we are putting the answer, the smoothed value, in the middle of the group, when I go to do that, so if I take this data here as an example, when I go to put it in the middle of Jan through to April, the middle of those 4 data points is in between February and March. And we don't have a time code there. We can't say it's at month number 2.5. It has to line up with an original time period. And so we have to do a second step or a second process, which is called centering our data. And so what that allows us to do is take, so say this value for February 0.5 or 2.5, and if we think our second group is going from February through to May, where the middle lines up with in between March and April, or 3.5, we can take these 2 values and combine them to get a number, a smoothed value that lines up with time code 3 or with March itself. So there's a 2-step process here where we are smoothing or finding the mean of a particular group size, and then we are going ahead and applying this process called centering, so that we're putting our smoothed value back in line with one of the original time codes, one of our EV values. So firstly, let's look at the process of 2 mean smoothing with centering. So the example we're using here is the maximum daily rainfall each month was recorded at a weather station, and the table shows the maximum daily rainfall for each month of a period of 1 year. So first thing we want to do, we're doing 2 mean smoothing. We're going to firstly take a group of 2 data points, so starting January, so we would be going January and February as our first group. Our answer for this value will line up at time period 1.5. So remember we said in the previous slide, it won't line up with an actual time period. To get this value, we are averaging the daily rainfall for those 2 months. So 79 plus 123 divided by 2. And there we get a value of 101. The second step is then going across one value. So now we're talking about February and March. And so now I'm looking at this group of 2. My answer will line up with in that, in the middle of February and March, or time code 2.5. Again, I'm adding those values, 123, 100 divided by 2 to get the mean or the average value of 111.5. My final step is then to combine those 2, so this centering process. And so when we're centering those values, we're now looking at these 2 values that we have found and averaging those. And our answer here will line up back in the middle of those 2 values. So we're lining back up with February, time code 2. So 101 plus 111.5 divided by 2 gives me my centered value of 106.25. So there's 2 levels to our calculations here. We find our 2 mean groups. We work along our table and find each of those. And then the second step, is to center those values back in line with one of the actual month numbers so that we're in line and we can draw that onto a time series plot. So if we were to continue on from there, if I just remove my first set, I give it a space, I'm going to keep my value there for the second little group. I'm going to move along to March and April, and so now I'm getting a value that lines up in the middle of 3 and 4. And so my values here would be 100 plus 156 divided by 2, because I have a group of 2. We get 128. And then again, our process here for centering, is take these two values and they will line up with March or time code 3. So 111.5 plus 128 divided by 2, and I get a smoothed value there of 119 or 119.75. And again, I would continue along. So the next group, I would use my answer 128 from March, April. I would find the two mean smoothed value for April, May, and then average those two answers again to center. You might find that it's actually more useful to work across the first row. So finding the off center, I guess the two mean group values first, and then going through the process of centering those. So just looking at the completed table of answers there, it can be useful to organise it underneath, or if your table is running vertically down your page to the right hand side. It is often though the case where you are asked to then take just one smoothed value from the table. So it may be that you're asked to calculate the two mean smoothed value with centering for the month of August. And so if we were asked to do that, first thing we want to think about is that August, we're going to need August to be the value that we center back in line with. And so in order to make that work, if we work backwards from there, the value 149.25 is a result of averaging or centering the two values directly above that. The value here on the left, 155.5, is a two mean valued smooth number. So it's come from the two values above there. So it's actually from month 7 and month 8, which feed directly down. And we're talking about month 8 and month 9 to feed down to give us that value of 143. So if I need to find August's value, another way of thinking about it is saying, well, I need one value that goes just on the left-hand border of August. I need a group of 2, so I need to drop down 1 month and include August there. Then I need a value that goes on the right-hand border of August. So again, include August, go up to September. So there's my two groups of mean values, to then take those answers and smooth them to ultimately get that 149.25. And so what impact does that have? For the sake of being able to draw a graph, I've just rounded those smooth centered values off to the nearest whole number. Note that whenever you are plotting their centered data or using it at all, you always use that centered data, so the final row in the table from the previous slide. So you think about the two mean values, the two mean smoothed values as your working row. Your final answer, your new data, your smooth data is the centered data. So we can see here it has taken out some of the fluctuation, still a bit of a rolling, even though I've joined those with straight lines. Still a bit of a curve there. It's not very linear, but we can see there is that increasing trend. The final example that we'll look at here is of 4 mean smoothing with centering. So much like our 2 mean, we are working with groups of 4. We are finding the average of that group of 4 data points but then we are having to do that second process of centering back in line with one of the time periods. So starting from the left of our data, if we first consider the first 4 dot points here, or the first 4 data points here. So we are talking about January through to April. The middle of that set of data will be lining up with February and March, in between Feb and March, or at 2.5. Our second set of points will be from February through to May. So a new group of 4, and again, centering that data will line up with the border between March and April, or at 3.5. And so our next step there is going to be to take those 2 values, those 2 answers we get, and center those so they'll end up in line with March. And much like our odd group sizes, we do lose some data points either end. And with 4 mean smoothing, we will lose 2 points at the lower end and 2 points at the upper end of our data because of the way these values are constructed. So to calculate those numbers, let's fill in some gaps here. So initially, to find my first group of 4, January to April, I'm doing 79 plus 123 plus 100 plus 156, dividing that by 4, and I get a value there of 114.5. I will then do something similar for my second group of 4. So I'm doing 123, 100, 156, and 174, divide by 4, and there I get a value of 138.25. To center that, take those 2 values, divide by 2, and I end up with a smoothed, centered value of 126.375. I then continue my way along the table, and each time, so now I can get rid of, I guess, that first set of working, the green there, and move along to my next group of 4. So I'm now working March through to June, and I want to make a calculation so that I can get the value that will sit in that border between April and May. So doing one more here, I would be doing 100 plus 156 plus 174 plus 186 divided by 4, and that would give me a value of 154. And so then my smoothed value this time, same idea as before, where I had 138.25 plus this new value of 154, divide that by 2, and my centered value 146.125. And so you can see that this process is quite lengthy, and again, highly unlikely that we would have to find a whole table worth of values. But it is really important that we know where these numbers come from, so that if we were asked, find the 4 mean smoothed with centering value for the month of September, we could go ahead and do that. So just looking at a completed sort of set of working here, again, just note I have rounded my smoothed centered values to the nearest whole number, just because it got quite cramped there. So in the bottom row here, these are my centered values, and these would be the ones that I would use for any future work. Much like before, if I did ask you to find the 4 mean centered value for June, you want to think about, let's go to that left-hand border of June, make a group of 4, so 2 data values to the left, 2 data values to the right, and we get our 4 mean value of 166.25. And then I'm going to do a very similar thing on the right hand or the upper border of June. So 2 values down, 2 values up or to the right, and my 4 mean smoothed value there, 167.25. 0.75. And then finally my centered value, notice that my centered value here of 167 is always just the average of the two values above. So you're just taking those two border values and bringing it back in line with the June value, regardless of how big the mean smoothed group is. And so finally here again, just showing you a graphical representation of that. So we have our smoothed centered values rounded to US whole number, and just showing you the impact of that for mean smoothing. So again, it has taken out more of that fluctuation, and we can see that underlying trend of the data there, and it would be potentially more appropriate to now apply a least squares regression line to make predictions and things like that with this set of data. So that gives you a snapshot of the main types of mean or numerical smoothing. Remembering you do need to know all of the underlying technique, but highly likely you're asked for one or two values that you would have to calculate. And we're seeing that mainly in multiple choice style questions as well. So it's good to have a really detailed example for yourself, so that in the event that you do see one come up, you've got a good basis to work from.